food defense plan. So we'll just brief about food defense plan, which includes vulnerability assessment to identify actionable process steps, and identification and implementation of mitigation strategies, management components. The mitigation strategies management components are food defense monitoring, food defense corrective action, and food defense verification, reanalysis. Reanalysis is required at certain times and under certain conditions, and training records. A vulnerability assessment is a systematic assessment of process steps or procedures to identify and rank vulnerabilities to intentional adulteration. Here, FDA has released guidelines for food defense plan improvements. Food defense monitoring, food defense corrective action, and verifications, these are all the procedures. Some of the procedures still in the draft guidelines only, and some procedures FDA not yet released. And some of the procedures like food defense corrective actions, soon they will release the how to take the corrective action procedures whenever any deviations occurs from the actionable process step or anything happens intentionally adulterated. What are the corrective actions? And maybe FDA will release that guidelines also. Now let us discuss about the next slide. The goal of the VA vulnerability assessment is the main goal of the vulnerability assessment is we have to determine each process step, the vulnerable assessment, whether significant or not. If the vulnerable assessment, while conducting the assessment, the vulnerability in that particular area is a significant or potentiality is there, then that is called as actionable process steps. Then same way the mitigation strategies and key activity type vulnerability assessment method. In this method, we will brief about the key activity type method, the CAT method background. Since 2004, FDA has conducted vulnerability assessment and identified mitigation strategies to protect the food system from acts of intentional adulteration under the other direction of home security. Since 2004, FDA has conducted numerous food defense vulnerability assessments on a wide variety of foods and processes with industry, academics, and other government partners. This vulnerability assessment research forms the foundation of FDA food defense program and informed the development of the intentional adulteration rule. Over the course of FDA conducting vulnerability assessment trends, a vulnerable points were identified which led to the identification of the CATS method. Now, in response to the passage of the Food Safety Modernization Act, FDA analyzed the vulnerability assessment data and found certain general activities that frequently occur in food processing operations consistently ranked as the most vulnerable regardless of the commodity being assessed. These became the CAT. Yes, FDA has conducted analysis in different food processing industries, dairy industries, bottling industries, canned meat manufacturing industries, bakeries, beverages, bottling industry, etc. And finally, FDA has noticed some of the processing steps which are frequently occurring in the food processing operations consistently ranked as the most vulnerable, regardless of the commodity being assessed. So these became the CAT, key activity type method later. A particular food is generally not more inherently vulnerable than other food to intentional adulteration. The main drivers of vulnerability are the processing steps and procedures that are used as food is moved from farm to table. From the results of the analysis, FDA conducted that 4 groups of processing steps consistently scored highly in the vulnerability assessments. These 4 groups of processing steps were identified as key activity type. At the conclusion of this analysis, FDA produced a detailed report on the development of key activity type. These 4 groups, now discuss about the 4 groups. The first one is bulk liquid receiving and loading. The second one is liquid storage and handling. Third one is secondary ingredients handling. The fourth one is mixing of similar activities. Using CAT are efficient science-based approach that comprisers may use to identify actionable process steps. Key activity group 1. Bulk liquid receiving and loading. Bulk liquid receiving refers to the inbound movement of liquid ingredients into a facility for its use in the food production process. And bulk liquid loading refers to the outbound shipping of liquid intermediate or finished product liquid from the facility onto a transport vehicle for further process use. So the group 1 key activity, bulk liquid receiving and loading. So receiving is inbound, loading is outbound for further processing. When we talk about the seafood industry, especially the seafood industry, because these bulk liquid receiving and loading may be significant for the dairy industries and some other like of bottling industries, some beverages industries, they comes under significant for these steps. Whereas seafood industry, food processing industry, seafood industry is concerned, the bulk liquid industry especially, whenever we are depending on water, water is an ingredient. Whenever we are receiving the water from outside the sources, or the facility who is having the water treatment unit at outside the facility due to maybe low levels of the water at the ground. So in such cases, or maybe the water they are getting from the municipalities or water they are getting from the other sources as an ingredient. So they must conduct the assessment, vulnerability assessment. So depends upon the flow and depends upon the designing, it may vary. The same process depends upon the design. Some facility may comes under significant vulnerability those steps, and some facilities may not comes under significant vulnerability on that particular step. If you are depending on the groundwater bore wells, so through the bore well we are taking the groundwater bore well, and then it goes to the sump and the water treatment plant, and after treatment the water which goes to the overhead tank, all are in an enclosed manner. So when the water is going in an enclosed manner, so pipelines, through the pipelines, no chances of contamination. And the facilities, the food industries especially, the water treatment area, they make, this is highly sensitive and restricted areas, they should prevent the entry, restrict the entry, and all the tanks should be lock and key condition. Only authorized persons only can able to access the entry, and without permission no one can be allowed. So those kind of precautions, whenever we take those kind of precautions, so that step will dilute, the potentiality will dilute, and it won't come under significant vulnerability. So on other way, if you don't have the enclosure system, if you don't have the restrict entry system, you don't have the lock and key system, then that will prone to the potentiality. The attacker can easily, you are facilitating him to easily adulterate the liquid. So we must take it into consideration, and by providing the closed circuit cameras at strategic locations where the vulnerable points are available during the process step. So we have to take it into consideration from farm to plant, or from the sources, water or maybe the raw material, or from the sources to the factory. We have to identify each process step, we have to conduct the assessment for each process step, and based on the assessment, by using the key methods, or by using the hybrid method, or by using the 3-element method, we have to come to conclude that whether which comes under significant vulnerability or not. In this case, the bulk liquid receiving and loading leads to a high probability of ingredient mixing, and thus an even dispersal of a potential contaminant throughout the liquid. These steps include large volumes of liquid and frequent worker access to the liquid and handling and equipment such as hoses. So that's why we must keep an eye, and we have to provide the CC cameras in this particular region. So that's why the FDA have identified the bulk liquid receiving and loading as the significant vulnerable step. This step is acceptable in the case of if you are receiving the liquid in the form of drums, sealed drums, in the form of sealed jars or sealed jugs or sealed tortoise. So we can give the exception because of you have to check the authenticity. If sealing is tampered, then you reject the product. If sealing is not tampered, you receive the bulk liquid. Then next we will come to the point. The second group is liquid storage and handling. Yes, liquid storage and handling. Yeah, liquid storage and handling refers to a step when a bulk or non-bulk liquid is contained in storage tanks or silos or in holding, sorts, metering or other types of intermediate processing tanks. So liquid storage and handling refers to a step when a bulk liquid. So the liquid storage refers to any storage silos or tanks may be stored prior to introduction into the food stream or prior to loading for outbound shipping. Bulk or non-bulk tanks can be used to store liquid ingredients, whole liquid products for sample testing and other quality control activity or to control flow through the production system. Handling tanks also include tanks or tortoise where the tamper-evident seals are opened and the container itself is used for holding. We have to take it into the consideration. At these steps, there is a high probability of mixing due to agitation, which would likely cause even dispensation of a contaminant and likely application to a large amount of servings. Yeah. Secondary ingredient handling. The third one is secondary ingredient handling, which includes any process step or procedure where dry or liquid secondary ingredients, inclusions, minor ingredients, processing aids or food additives are manipulated by human contact prior to or during addition to the product stream. We must avoid these kind of things. So, which includes the storage of partially used or open containers of secondary ingredients where the tamper-evident packaging has been breached, does not include computer metering, automatic weighing. These activities are generally open, accessible point at which a contaminant may be added, then distributed to a larger volume of a main product flow. Secondary ingredient handling. Because why? Because for preparation, especially the food industry, seafood industry, we have to add some additives like phosphates, non-phosphates, sulfites, some color additives. So we have to prepare the secondary ingredient handling. So this is the step which poses the potentiality if we have not conducted the assessment, if we have not established this process step as an actionable process step, then there may be the chances of adulteration intentionally. If the unhappy worker or sabotage, whatever it may be the waste. Why? Because if you're adding paprika dye, if you're adding sodium metabolism treatment, if you're adding phosphates or salts, whatever it may be the chemicals, especially in the shrimp industries. So this step is considered as the significant vulnerability step because of probability is more. These activities are generally open, accessible points at which a contaminant may be added, then distributed into larger volumes of the main product flow. Stacking, preparation and addition, so which facilitates an attacker to contaminate the product, includes storage of partially used open containers on secondary ingredients where the tamper-evident packaging has been breached. We have to check each and every time whenever using anything which is breached, if the seal is there or not, seal broken or not, if any suspicious activity, if you notice any suspicious activity, immediately you should communicate to the top management. Then they will do the analysis whether it has been adulterated or not. Based on that, they will take the corrective action. Next, the last fourth one is key activity type 4, mixing and similar activities. Yeah, a process step or procedure where the primary purposes or result of mixing. So to blend a powder or to blend a phosphate or salts or water, maybe homogenize different methods which facilitates adulteration, mixing of this thing. For example, if you are doing the breading, if you are doing the dusting, wheat flour coating you are giving, these are the steps where the attacker can easily adulterate the food. So we must keep an eye. We have to identify this step as a vulnerability, significant vulnerable step in shrimp industry, because of while doing the coating or while breading, while glazing, while flavoring, while battering, number of axis, degree of physical axis will be more, and the attacker can easily adulterate the food. The potentiality also more. That is why this step also considered as a significant vulnerable step. Frequently includes use of equipment such as mixers, blenders, other cascade tile applicators. Successfully add contaminants at this step would generally be evenly dispersed throughout the product. Accessibility through access points, lids, in-feed conveyors, flumes, etc. Yes, these are the accessibility through access ports, leads, in-feed conveyors and flumes. These are the things. And now the third method for conducting the vulnerability assessment. This is the most advanced method. This is the most advanced method. I will show you the assessment report in my next video, fourth video. I have conducted vulnerability assessment based on hybrid method, CAT and 3-element method. By using these two methods, I have assessed from raw material to shipment, from farm to shipment. Each process step I have conducted assessment, identified the vulnerabilities and established the mitigation strategies, everything. I will explain in my next video, and I will just briefing you about this hybrid method, why this is more advanced and more actionable steps. When using worksheet for documenting the hybrid approach, we should utilize 3 fundamental element analysis is used in combination with the CAT analysis. Yes, so we have to use both the methods in combination of CAT and 3-element methods. This is in my next video I will explain you. And the fourth one is others. Others means the food professionals are PCQIs, preventive controls individuals who are having experience in the food industry. Based on the scientific evidence, based on the data, they can develop their own method.